Hi everyone! Welcome back to integralcalc.com. Today we're going to be talking about how to eliminate the parameter, and in this case we've been given the two equations x equals 5 cosine of t and y equals 3 sine of t, and what we need to do is define these two equations in terms of x and y only and eliminate t as a variable. T is the parameter and we need to eliminate it from these two equations, and the way that we do it is by solving them together as a system of simultaneous equations. And there's going to be a few steps involved in doing that, but basically when you're eliminating a parameter, if you can solve one of the equations for t and then plug that into the other equation, then you can quite easily eliminate the variable. So let's go ahead and try to solve the x equation, the x equals 5 cosine of t, for t, and then plug it into the equation that's set equal to y. So the way that we'll do that is first by dividing both sides by 5. So we'll get x over 5 equals cosine of t. And then to get t on its own, we'll take the inverse cosine function of both sides. So we'll get cosine to the -1, which is the inverse cosine function, of x over 5 equals, and when we take the inverse cosine function of cosine of t, the inverse cosine and cosine will cancel and we'll just be left with t over here on the right hand side. So now that we have t defined as the inverse cosine function of x over 5, we can plug this in to this variable here, for this t variable, into the y equation. So we'll get y equals 3 sine of cosine of -1 of x over 5. And as you can see, we've now eliminated the parameter because we have no t variables involved in our equation. We just have x and y. But now we need to go ahead and simplify this as much as we can. And that's what you'll need to do with any of these kind of problems, is first eliminate the parameter, but then obviously, as with any kind of problem, simplify as much as you can. And in this case, the way that we're going to need to do it is with the Pythagorean Theorem, which I've written down over here. Sine squared of x plus cosine squared of x equals 1. You'll remember it from trigonometry. And what I've done is created this formula here for us that's going to allow us to evaluate this sine of the inverse cosine function. And you can derive that from the Pythagorean Theorem by plugging in cosine to the -1 of x, or the inverse cosine of x, for both of these x variables here. If you do that, then obviously you can see we're going to get this step here. Again, this cosine and this one will cancel. You'll be left with x squared over here. Then if we subtract x squared from both sides and then take the square root of both sides to eliminate this squared term here, we'll get sine of the inverse cosine function of x equals the square root of 1 minus x squared. So knowing that, in our particular case, we have x over 5, which is going to be equal to x using this formula. So we're going to plug that in to this right side here for x. And when we do that, we'll get y equals 3. And then this whole piece here is going to be transformed with the formula. So we're going to have 3 times the square root of 1 minus x minus 5 squared. And now it's just a matter of algebra. We will create one fraction under the square root sign by changing this 1 here into 25 over 25, which is the same thing as 1, because this x over 5 squared term is going to become x squared over 25 when we square it. So now we can get the square root of 25 minus x squared over 25. We just found the common denominator there of 25. And remember that when you have the square root of a fraction, you can take the square root of the numerator and denominator separately. So we'll end up with 3 over 5, because the square root of 25 in the denominator, that's 5, so that comes out, and we're just left with 25 minus x squared inside the square root sign here. And now, if we wanted to, we could square both sides. I'm going to move this 3/5 over, and I'm going to get 5y over 3, multiply both sides by 5, then divide both sides by 3. You'll get 5y equals 3 equal to the square root of 25 minus x squared. And it would be cleanest to eliminate the square root, so I'll go ahead and square both sides to get 25y squared over 9 equals 25 minus x squared. And now if I want to multiply through both sides by 9 to eliminate the fraction, I'll get 25y squared equals 225 minus 9x squared. And then I'll just go ahead and add 9x squared to both sides. So I'll get 9x squared plus 25y squared equals 225. And that's the cleanest way to write it, having both variables on one side like that and then the constant. So this will be our final answer, 9x squared plus 25y squared equals 225. We've eliminated the parameter t and simplified the equation as much as we can. So that's it. I hope this video helped you guys, and I'll see you in the next one.